Welcome back to my channel, students. It is the Quest Edu Physics and we are discussing about the Newton laws of motion. We are talking about the forces. In this video, we are discussing about the friction, or simply we call it as the frictional force. First of all, we have to understand what is the definition of the frictional force. It is the force which tries to stop the relative motion between the two bodies which are in contact. Frictional force is the force which tries to stop the relative motion between the two bodies which are in contact. Okay, students, and you have to remember that when a body is resting over the another body, no frictional force will act, but it tends to move over the other body, then the frictional force will develop. Let's say it's a surface, okay, with friction, that means rough surface. We kept a body over, okay, here the body which is kept over the surface, and let it has a mass of m. Let's say how many forces are acting on this body. Obviously you would say is the weight of the body which is working vertically downwards, and you know that weight is equal to m1g. Is the action which is acting over the surface, then a reaction will act. Okay, it is the normal reaction. These two forces get balanced with each other. That's why we said there is no extra force acting on. Here frictional force is the force which tries to stop the relative motion between the two bodies which are in contact. Now say it is a line of the action of force. I am applying a force which has a magnitude of F, and there would be a chance whether this body, this force, can make this body to move or not. It depends upon the applied force. Okay, students, yet then immediately when you apply a force on this body, immediately a force will develop in opposite direction to the applied force, okay, and we call this force as frictional force. The force which immediately develops to stop the motion of this body over this surface. That's why when giving this definition I said is the force which tries to stop the relative motion. The relative motion, that means the motion of a body with respect to another body, is known as the frictional force. I hope you are understanding what is meant by the frictional force. Now what happens, you have to remember one more thing while you are learning about the frictional forces. Actually, frictional force is a self-adjusting force. It is the self-adjusting force. Okay, students, then what does it mean? If we apply the force, that means applied force, if we are increasing the magnitude of the applied force, then immediately the frictional force also increases. That means what? The magnitude of the applied force is directly proportional to frictional force offered by the surfaces in contact. And you have to remember one more thing here. Frictional force always acts along the direction of the forces. That means what? The body is in contact. It works along the line, okay, where the surfaces are in contact with each other. That's why it is a contact force, and this is what that also stated as an electromagnetic force. The frictional force is electromagnetic force. Actually, frictional force develops due to the irregularity of the surfaces. Frictional force develops due to the irregularity of the surfaces. What happens here? When the one surface is kept over the another surface, I said the surfaces have the irregularities. The irregularities get what? Locked with each other. Let's say it is one surface, it is irregular. I kept one more, it also has the irregularity. Okay, when I kept it over, then what happens? These surfaces get interlocked with each other. This interlocking is the cause of friction. The cause of friction is the interlocking of the surfaces due to their irregularities. If you go in microscopic view, you can see what is that when a body is kept over the another body, the frictional force will develop. Then how it develops? Here you know that all the substances are made of atoms and they have the electrons in outermost orbits. We call them as free electrons. They can be removed very easily. When we push a body over the surface of other body, what happens? The electrons can drift it from one place to another. When electrons get different, what's that? Move from one place to another. Then what happens? One get more positive charge and other surface get the more negative. And you know that negative get attracted with the positive. In that way, friction force will develop. Okay, students. Friction is due to the irregularity of the surfaces, and friction develops only when one body is tends to move over the another body. When a body is resting over another body, there is no presence of frictional force. Let's see about the types of friction. Okay, students. Actually, friction is classified into two types, students. Okay, friction can be classified into two types. One is static friction. Okay, students, it is the static, and the second one is the kinetic friction. It is static and the second is kinetic friction. Okay, students. Now we are going to learn about what is the static friction is. Simply, it is nothing but the definition what you have learned before. Okay. Here it is the force which develop. Okay, when one body tends to move over another body. When a body tends to move over the another body, it can be understandable very easily. Let's say I am holding this one in my hand. I can hold it very easily. Just imagine I put more weight on. Okay, I have to apply some more force on it. Then if I keep one more, then what happens? I have to apply more force. I am adjusting my force. See, I am applying some more and more and more. Then what happens? At a particular point, my capacity will breaks down and I make, what's that? My hand can't hold these weights and it fall down. Understanding me? The thing what did happen till now, up to which I am holding, is nothing but the static friction. Okay, where my capacity broke down. Okay, that is the limiting friction, students. That's why I said friction is a self-adjusting force. Okay, students. Then see, it can be understandable very easily. Let's say it is a surface on which I kept a body, and you know that as usual weight works vertically downwards. There is a normal reaction. I am applying a force here. Okay, is the frictional force which is working opposite to the direction of the applied force, and both are both have the magnitudes of F and small f respectively, and the frictional force acts along the surfaces in contact. Understanding? Here I can't say the body will move by the application of a force. It can be moved or cannot be depending upon the magnitude of the force. When I apply the force on, then what happens? The frictional force will develop. That means we have a direct relation between them. Okay, we have a direct relation between them, linear relation. If it increases, it also increases. Let's say I am applying a force of 1 Newton. Then a force of 1 Newton develops in. Then I change the force to 2 Newton and it turns to be 2 Newton. And if I increase to 3 Newton, and it could be 3. In this way, this force is adjusting by itself. That's why we said frictional force is the self-adjusting force, and I am increasing in that way. What happens after applying a force? Say, let's say I applied a force of 20 Newton. Okay, what did happen? The body tends to move. Okay, the body tends to, what's that? Tends to move. Till now it tends to move. Then after, the body, what's that? Started moving over the surface. That means what? At a particular force, the breaking capacity of this frictional force, what's that? What's that? The frictional force lost its capacity and it breaks down, then the body is moving over. Understanding me, students? At a particular point, what happens? It lost the capacity of resistance. Resisting capacity is lost by this force. Then the body is moving over the surface. Okay, that's why I said frictional force is the self-adjusting force. And where the body, is moving over the surface, we call it as the limiting friction. Okay, students, limiting friction. Limiting friction is a particular force, is a certain amount of the force. After that, the body moves over the surface. That means what? The body, undergo the motion. Understanding me? Till the limiting friction. Okay, the body doesn't move. Then after, what happens? It tends to move. That one is known as the limiting friction. Limiting friction is the maximum value of the static friction. After that, the body moves over the surface. I hope you understood. This can be understandable very easily by a graph, students. We can say it as force versus, okay, frictional force graph. Okay, students, let's take this graph and we have to study this. Okay, students, here is the x-axis, which is the origin, and here is the y. I am taking applied force on x-axis and frictional force on y-axis. I said it is the self-adjusting force. I am taking some points here. That means different magnitudes I am taking. Let's say F5. And we have F1 frictional force I am showing is F2, F3, F4, and it is F5. I said no frictional force will develop when a body is resting over the another body. When a body is resting over the another body. That means what? Here, initially the applied force and frictional force is 0. Then the force has been increased to F2. Then automatically frictional force will increases. I am locating this point. Okay, then after we increase to F2, then frictional force is, what is that? F2. Okay, then further we are increasing. It changed to F3 and then it is F4 and it is F5. Okay, let's join all these points, students. Let's see what could happen. It appears to be a straight line which is passing through the origin. Okay, it is a straight line which is passing through the origin, and here it's making an angle of 45 degree. What does it mean? They have the linear relation. If one increases, automatically the second also increases. Okay, students, after reaching a particular point, what did happen? What is that? It reaches, the frictional force reaches a maximum value of the static friction, and we call it as the limiting friction. Then its, what is that, opposing capacity will breaks down. Okay, the body begins to move. If we represent this one, it can be shown in this way. Okay, students, here if you locate the points, we can say it's the point where the body, that means what, lost the capacity of opposing, and we call this Fy as the limiting friction. In that graph, Fi is the limiting friction. Then, okay, the body tends to moving. That is, F4 is the kinetic friction, students. F4 is the kinetic friction. If you watch it clearly, you will find here F4 is the kinetic friction. If you watch it carefully, you will find Fi is greater than F4. F4 stands for kinetic friction. Okay, after this point, the body undergoes, what is that? Motion. Okay, often we observe this, what's that phenomenon in daily life also. Okay, when I'm a child, I used to travel in bus. Sometimes the bus, what's that, breaks down. Then maybe it happens now also. People come out from the bus and they push the bus to an extent. Then after, what happens? Is that the bus starts moving. Then only few people can push the bus easily. Understanding me, students? The people who pushes the bus initially, they are, what's that, trying to reach what? The limiting frictional value. After that, few people come out and some are only able to move the bus. That is the kinetic friction. I hope you understood what is the static friction and what is the kinetic friction. And you have to remember that friction is a self-adjusting force. I showed here, if you are increasing the applied force, the frictional force is also increasing. After reaching a particular point, it lost its opposing, what is that, nature. Then the body is moving over the surface. Till then, the body tends to move over the surface. Then after, the motion will begin. Till it tends to move, we call it as the static friction. The maximum value of the static friction is the limiting friction. Then after, the motion will start. That means the body move over the surface. That thing is known as the, what is that, kinetic friction. I hope you understood what is the difference between the static friction and as well as the kinetic friction. Then after, we will learn about the laws of static friction. Okay, students? Okay, we can state the first law like this, students. Let's say it is a surface and a body is lying over the surface. It has a mass of m and we are applying a force. Then a frictional force will develop which works along the line joining the two surfaces. It is in opposite direction. Okay, with that we can say frictional force. Okay, first law can be stated like this. Here is the weight of the body which is acting vertically downwards. It is equal to mg and it is the normal reaction. The first law can be stated like this. The magnitude of the frictional force, is directly proportional to normal reaction. I mean magnitude of the static frictional force. In other words, you can write Fs is equal to mu s into n, or mu s is equal to Fs by n. Okay, students, here what is this? Static friction upon normal reaction. Okay, these two are the forces, frictional force and as well as the normal reaction. Frictional force and normal reaction are the two forces. That's why the ratio is equal to 1. So, quotient of friction, we call mu s as the quotient of friction. Okay, students, mu is known as, it is quotient of static friction, and if you write it as the mu, it is known as the coefficient of friction. Okay, students, Here mu s is equal to Fs by n. Being a ratio, it doesn't have any units. Then the body tries to move over the surface. It is moving with a velocity. Then this frictional force turns into Fk. And we can write the relation as Fk is directly proportional to n. Okay, students? Or Fk is equal to mu k into n, and mu k is equal to Fk by n. Here mu k is quotient of kinetic friction. Here first law stated that mu s is equal to Fs by n. That means frictional force, static frictional force is directly proportional to normal reaction. And the second law, it is valid for all kind of frictions, the both laws. Here frictional force doesn't depends upon the area of contact. Okay, students, frictional force doesn't depends upon the area of contact. Okay, students, and the best example is that a small brake can stop a big vehicle. If you are the young guys who are pedaling the cycle, you know that cycle is provided with two small brakes. Okay, these brakes are capable to stop the running cycle. Okay, students, frictional force doesn't depends upon the area of contact. Okay, students, it is static friction and it is the kinetic friction. Then after, the third one is the rolling friction. Rolling friction is one of the applications of kinetic friction, students. Okay, here it goes with the bodies which are in circular shape. Okay, here the area of contact is very less. It is the rolling friction. Okay, students, then we have to write a relation between these three types of friction. Okay, here it is static frictional force and it is a kinetic frictional force and it is the rolling friction. Fs is always greater than Fk and Fr, or you can write Fr is less than Fk and less than Fs, or mu s is greater than mu k is greater than mu r, mu r is less than mu k is less than. Yes, we can relate this quotient of frictions in this way. Here my intention is static frictional force is always more than the other frictional forces.